Alrighty, guys and gals. In this episode, oh, it's like a blooper. In this episode, liberty mutual, liberty bibbity, liberty bibbity. But honestly, in this episode, we are going to discuss organic and inorganic molecules. Here, we're going to focus mainly on water, which is an inorganic molecule. So first off, those organic molecules, maybe a family member, not organic molecules, organic bananas, a family member buys at the supermarket. Yeah, that has nothing to do with any of this here. So, definition of organic molecule is any molecule that contains carbon and hydrogen. Where inorganic molecule, obviously, it doesn't contain both carbon and hydrogen. So, H2O, water, obviously an inorganic molecule. It doesn't contain the carbon, both carbon and hydrogen. It has hydrogen, but doesn't have the carbon, so it's by definition an inorganic molecule. So let's look at some characteristics of water here. So water, first off, is polar, so there's a slight separation of charge there, which means water is a great solvent, so it'll dissolve charged particles and polar molecules as well here. So think of how many things water dissolves in, whether it's Crystal Light packets, whether it's sugar, anything that's polar, anything that is charged will dissolve in water. It is a very good solvent there. And also, water is a great transport medium. So our blood, which is mostly water, transports nutrients throughout the body. So if we didn't have that transport mechanism, the blood, the brain wouldn't get nutrients, oxygen, the fingers wouldn't get nutrients, oxygen, your digestive organs wouldn't get nutrients, oxygen. Nothing really would function if we didn't have this transport medium of water, which is pretty much blood, just circulating all the oxygen, CO2, nutrients throughout our body continuously here. It's pretty magical. Well, not magical, but it's pretty awesome stuff. It really is. But just think of how ships used to be the main means of transporting goods from one continent to another. Water is a great transport medium. So water is great with ships transporting from continent to continent. Also great in our blood transporting nutrients there. Water also this is still under the water is polar, kind of broader umbrella there, but water is a great lubricant, so it'll decrease friction and increase movement, and this is great. There's a layer of water surrounding the heart to allow it to decrease that friction, which increases the movement, allows it to pump. I hope it's pumping. If it's not pumping, I would stop watching this video and go to the hospital, probably, if it's not pumping. But we obviously know that's not the case. If it's not pumping, good night. But if just think of an analogy to this, if washing your hands with just soap, it doesn't work out too well. But if you add that water with the soap, hands can rub together much more smoothly and easily. And that's because water is that great lubricant to decrease friction and increase movement. Also, water is chemically reactive, so getting back to those catabolic reactions, water, it aids in many catabolic reactions in the body. So you eat food, drink water. Water helps to actually break down that food in our body into raw materials and energy, really, that we could build and use to build other things in our body, whether it's muscles, whether it's utilizing it for energy to produce ATP. But water helps to break down the food we eat to allow it to be utilized, pretty much. So just think of how iron, the Pittsburgh way of saying it, think of how iron starts to rust if exposed to moisture there. So you leave your, bike or a trailer out, and it gets moisture on it, it's going to start to rust because water is chemically reactive. So even though it seems kind of it's kind of innocuous, not very harmful, it actually will eat away at iron, and it obviously eats away at the food we eat as well too. So just think of how things rust due to water or moisture as an analogy as water being chemically reactive. So water is polar, which means it's a great solvent, great transport medium. With the ships sailing from continent to continent, it'd be pretty damn cool if they could drive. And a great lubricant, decreases friction, increase movement. Water's also chemically reactive, but water also, two more main characteristics of water. It has a high specific heat. So specific heat is the amount of energy required to change the temperature of something. So just the specific heat really is changing the temperature of anything by 1 degree. With water, It has a high specific heat, so it takes a lot of energy to change the degree of water by 1 degree. Just think of how long it takes an ice cube to completely melt if you set it out at room temperature. So it's quite a difference from below, or at least 32 degrees, compared to, say, room temperature at 70 degrees, or whatever room temperature may be for you. It takes quite a long time for water to melt, and that's due to its high specific heat. Or just think of, in the summer, swimming pool, how long it takes for the swimming pool to actually become warm. It takes weeks, days, perhaps even month of sunshine. If it's sunny for 2 days and we had a stretch of, say, like 50 degrees, water's not going to be too warm yet. It does take some time because of that high specific heat of water. It takes a lot of energy to change water by 1 degree Celsius. And water, last but certainly not least, is a high heat of vaporization. So requires a lot of energy to evaporate water is pretty much what that means. So high heat of vaporization. If it was a low heat of vaporization, it wouldn't require much energy to evaporate water, but water has a high heat of vaporization, so it requires lots of energy to change, or to evaporate water, excuse me there. So it somewhat ties into the specific heat side of things, although it is a different characteristic of water. Just think of how hot the stove needs to be, as okay, we did a little low power mode. We're running out of battery. Better hurry up here. But just think of how hot the stove needs to be, as well as for how long to boil water. So to pretty much evaporate water, it takes a lot of time to boil just one pot of water, going from a just from room temperature to boil. So it takes lots of energy to change, to evaporate water. So that in our own bodies, this is actually how we stay cool whenever we sweat. So sweat is just pretty much water going onto the skin, but the heat in the blood, it's such a high temperature of heat in our bodies, obviously 98.6, but it may raise whenever we're working out or something like that. The heat from our blood actually evaporates that water, which releases energy, releases heat, and that helps to keep us cool. So sweat, it's actually a good thing for us. It's a helps thermoregulate us, or keep us, our temperatures at a nice happy balance. So the sweat or water evaporates, which releases heat. So we need to evaporate the sweat in order to keep us cool in our bodies, and that's due to the high heat of vaporization. It takes lots of energy to evaporate that water, so lots of energy being released, which helps maintain our body temperatures there. So the four main characteristics of water is water is polar, water is chemically reactive, water has a high heat, or high specific heat, excuse me, and water also has a high heat of vaporization there. So water, inorganic molecule, doesn't contain carbon and hydrogen, is a pretty awesome molecule, and extremely important, as our bodies are 55 to 75% water. That's crazy stuff. But we'll see you back here soon.